MEO class 4 electrical written numericals. You can see question on the screen. The primary and secondary windings of a 30 kilovolt ampere 76,000 to 30 volt one phase transformer have resistance of 10 ohm and 0.016 ohm respectively. The reactance of the transformer referred to the primary is 34 ohm. Calculate the primary voltage required to calculate full load current when the secondary is short circuited. What is the power factor of what is the power factor on the short circuit? Now, whatever we have in the question, we will write it. So here, rated power given. How much? 30,000. And rated voltage given for primary and secondary given. Primary resistance R1 is 10 ohm and secondary resistance is also given. As we know that in transformer there is a primary side and secondary side. Voltage is also given for primary side and secondary side, and resistance is also given. Now reactance referred to primary is 34 ohm already, which is this is given primary side. We need prime to calculate. We need primary voltage to calculate the full load primary current when the secondary short circuited, the power factor under the short circuit condition. For the short circuit condition, we have to calculate primary voltage and power factor under the short circuit condition. Now, what is the rated primary current? So it is simple, as we know that power is equal to Vy. So I rated is equal to power divided by rated voltage. So this is the current we will get for rated primary current. Okay. Next, refer secondary resistance to the primary. Now we have we will find voltage ratio. We will use voltage ratio. So it will be 7600 divided by 30. This will be this will be your voltage ratio. How will you get? Simply we have voltage for primary and secondary given. So we simply get it. Okay. Now now we have to calculate secondary resistance. What we will use this formula R2 dash. R2 is already given. Secondary coil resistance is already given. So use this formula. Then we will create secondary resistance to the primary. Now what will the primary resistance? So primary resistance is equal to R1 plus R2 dash. R1 is already given 10 and R2 dash we already calculate. So primary resistance we can get. Secondary resistance how we already calculate, you can see. And for calculating primary resistance, this is all for the condition of short circuit. Now total series impedance is given, and as we know that total series impedance is equal to R total, and this is the inductance and capacitance we will add here. So total value is given and this is impedance is given in the question. So this will be the total series impedance, and value, as we know that this will be under root of a square of both. One question we already solved when to find magnitude, what we use under root x square plus y square. This is the x component and this is the y component. This is written in the vector form, and and yes, or there are many methods to solve this. So this is written in the simple vector form. So simply use this formula, and phase angle, for phase angle this will be, you simply form the triangle, right angle triangle. So simply this is 5 and this is 34 and this is 27.4699 and this is 43.71. So simply you can apply tan 5 and you will get this one. So this is as simple, and very simple. Now what is the primary voltage to circulate full load current? So simple voltage formula, as we know, V is equal to IR. So simply I1 rated we calculated and Z is the total impedance. When we apply the formula and put the value we already have, we will get primary voltage required to circulate full load current. Okay. Power factor on the short circuit. Power factor formula, we know cos pi. Pi is the phase angle, and phase angle we already calculated above. Put the value, we will get power factor. Okay. And lagging and leading, we check value of x, that is z, in total impedance value r plus z x. So this value decide lagging and leading. If x is greater than 0, it will be lagging and it is inductive. So this is all about this question. We already solved this problem. Thank you.